Actions speak louder than words. Agent decisions reveal implicit biases in language models. This work is a joint effort between me and my advisors here at Shirado. I'd like to start with a very simple step. Question, we propose this technique. We use language agent decision disparities to measure the implicit biases in language models. This is a two-step technique, and the first step is to use the demographic attributes, for example, female, and a context of the scenario to generate the name and the persona for an agent. And then in the second step, the agent is asked to role-play with name and persona in a given scenario. It is asked to make a decision in a scenario. For example, we ask the agent to decide whether or not to evacuate in a predicted flood. Pretty simple, right? So let's see the result. Here is the result based on GPT-4o. And this model showed no biased responses when explicitly asked. But when you create female or non-binary coded agents and simulate their behavior in an emergency, they are much more likely to evacuate than male agents, even though you don't design or intend this difference. This shows that language models reveal gender biases in behavior simulations that don't appear in explicit asking. This is not the only scenario we tested. In another scenario, we asked the agents to decide whether or not to join a protest when instructed not to by an authority. We found that 100 out of 100 Black-coded agents and 100 out of 100 Native American coded agents chose to join the protest. However, only 1 out of 100 Asian coded agents joined the protest. In total, we tested 4 scenarios and 3 different demographic groups across 6 different language models. The scale of implicit biases vary, but we actually found that implicit biases in language models are consistent. You may remember this figure from the beginning of our talk, where we found that explicit biases in language models drop with the advancement of models. But what about the implicit biases reviewed by behavioral simulations? Very surprisingly, we found that more advanced models show stronger implicit biases. You can see that GPT-4o shows way significantly higher implicit biases than GPT-3. This should suggest that alignment does not mitigate implicit biases, and it may even worsen it. So what does this mean? Our findings suggest that even advanced language models show socio-demographic-based biases in behavioral simulations. And our finding calls for alignment efforts that address not only explicit biases, but also implicit biases. And further, our technique actually opens up room for red teaming against implicit biases in language models. Because our technique can support arbitrary combinations of demographics and scenarios. And people can use our technique to red team against implicit biases at scale. With that said, we have one more question to ask. Should all implicit biases in language models be mitigated? To answer this question, we did a comprehensive review. We tried to compare the implicit biases in language models with real-world disparities in human groups. This is one of the statements we found that hold true. We actually found that extensive research support this statement. Females are more likely to evacuate in emergencies than males. This statement here is based on empirical studies of real-world disparities. And this is not the only statement that we found that hold true. In total, we made 6 predictions based on our review. And all 6 of them directionally aligned with the implicit biases in language models. So our findings actually suggest that advanced language models' implicit biases can align directionally with recorded real-world disparities, although the magnitude of these disparities are often amplified in language models. So we actually argue that implicit biases misaligned with real-world patterns should be mitigated, as they are both harmful and fail to accurately represent human behavior. But for biases aligned with observed real-world differences, the degree of mitigation should be determined responsibly based on why the simulation is being conducted and how it will be used. For example, policymakers might use simulations to test the impact of interventions across diverse subpopulations. While some biases may reflect historical inequities rather than current realities, and these biases should be mitigated, others may need to be retained to better estimate policy effects. For example, if females really do evacuate more than males in disaster scenarios, this bias may need to be present for an accurate simulation. With that, I would like to end our talk. Our work is funded by NNSF and NAMI's Foundation. And please feel free to scan a QR code to check our paper. And thanks for listening.